Bright QT. Every student matters.
Triangle ABC and triangle DBC are two isosceles triangles on the same base BC. Okay. Vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, show that triangle ABD is equal to triangle ACD. So, let us first of all look at the given information. It is given that these two are isosceles triangles. So, I can say this angle is equal to this angle here, right. Triangle ABC is an isosceles triangle on the base BC, right. So, base angles B and C are equal. Triangle DBC is also an isosceles triangle. So, DB is equal to DC, which means this angle here is equal to this angle, because of angle opposite to equal sides are equal. So, if this is theta, this complete angle is also theta. Now, look at these two angles. This angle is theta minus alpha and this angle is also theta minus alpha. So, these two angles are also equal. Okay, this much information I have with me, and side AB is obviously equal to side AC, right. Now, look at these two triangles. First question, triangle ABD and triangle ACD. In triangle ABD, AB, side AB is equal to side AC, because it is given that triangle ABC is isosceles triangle with base BC. Okay. So, the equal sides are AB and AC. Okay. And it is also given that DBC is also isosceles. So, DB is equal to DC and it cannot be in any other way, right. So, these are the equal sides, DB and DC, AB and AC. So, AB is equal to AC, it is given. DB is equal to DC, it is also given, right. And angle ABD is equal to angle ACD. Why? Because we have proved both are theta minus alpha, right. So, by side angle side congruence criteria, I can say triangle ABD is congruent to triangle ACD, right. This much was simple. Now, look at this triangle ABP, triangle ACP. Which one is triangle ABP? So, this complete triangle is triangle ABP and this is triangle ACP. Okay. Now that I have proved that triangle ABD is congruent to triangle ACD, I can say that this angle here is equal to this angle. Why? Because these are corresponding parts of congruent triangles. So, angle BAD is equal to angle CAD by CPCT. Why I have written this? Because I need to prove this triangle ABP is congruent to triangle ACP. So, these two sides are already given as equal. This side AP I will take as common side. I was just looking for the angle included between these. Now, I have found these angles as equal angles because of this correspondence here, because of this congruence here. So, now in triangle ABP and triangle ACP, this is the second part. Okay. AB is equal to AC, it is given, right, and AP is equal to AP, common to both the triangles. Angle included between these sides, angle BAP is equal to angle CAP. This we have already shown by CPCT, right. So, side angle side by side angle side congruence rule, I can say triangle ABP is congruent to triangle ACP. So the second part is also done. Now look at the third part. AP bisects angle A as well as angle D. Now this AP bisects angle A, which we have already shown, right, because this angle is equal to this angle here, right, this we have already shown. Now we need to show that this angle is equal to this angle here. Now this is also pretty easy, because this angle APB is equal to angle APC. So these two angles are equal and these form a linear pair. So we can show that both of these angles are 90 degrees each, right? And when you look at these two triangles, two angles are equal, hence the third angle will also be equal. So these two angles will also be equal, right? So you can show that these two angles are equal very easily. Okay, and there are other ways of showing it too, but I leave this to you, how you show them to be equal. I have given you enough ideas. AP is perpendicular bisector of BC. This also I leave to you, because I have shown that these two angles are equal, both are 90 degrees. Now by CPCT you can say that BP is equal to PC, hence AP is perpendicular bisector of line BC. So these two parts you will write yourself. I have given you the idea. Okay. AD is an altitude of an isosceles triangle ABC, in which AB is equal to AC. So there is this isosceles triangle ABC where AB is equal to AC, and AD is altitude. So this angle is 90 and this is D. Okay. Now we need to show that AD bisects BC. So if AD bisects BC, BD will be equal to DC. So we need to prove BD equal to DC. Okay. And what is given? Given is that AB is equal to AC and angle ADB is equal to angle ADC, and it is equal to 90 degrees. Right, this angle is 90 degrees, because it is given that AD is altitude. Now these two things are given. Look at these two triangles. Let me tell you first, so that you can pause the video and do it yourself. Okay, otherwise you come back and see the hint. Now see, in this triangle and this triangle, these two angles are 90 degrees each. This angle is equal to this angle and both are equal to 90 degrees. So these two triangles are right angle triangles and their hypotenuse are equal. Okay, and one side is common to both these triangles. So by RHS congruence rule, we can say that these two triangles are congruent, and by CPCT we will say that BD is equal to DC. Okay, so this is how we will proceed. Now you can do this question yourself. Otherwise, look for the hint in my solution. In triangle ABD and triangle ACD, AB is equal to AC, angle ADB is equal to angle ADC, both are right angles. AB is equal to AC, it is given, right, and side AD is equal to side AD, it is common to both the triangles. So I can say that triangle ABD is congruent to triangle ACD because of RHS congruency criterion, right. Hence BD is equal to CD, BD is equal to CD by CPCT, and we can say that AD is bisector of BC, bisector of BC. Okay, AD bisects angle A. Now look at this angle, angle BAD, angle B BAD, it should be equal to angle CAD by CPCT. So, I can say that angle BAD is equal to angle CAD by CPCT. So, this angle BAD is equal to this angle CAD, hence AD bisects angle A, hence AD bisects angle A. Now, what did we learn from it? That if there is an isosceles triangle and these are equal sides, if I drop a perpendicular, if I draw this altitude, this is altitude, right? It is also perpendicular bisector. It is also perpendicular bisector of the third side. It is also angular bisector of the, it is also angular bisector of the unequal angle, you can say. These are base angles, right? So, of this angle, it is the altitude is perpendicular bisector as well as angular bisector as well as altitude in case of an isosceles triangle, right? Two sides AB and BC and median AM of one triangle ABC, this is triangle ABC, and these are respectively equal to PQ, QR and median PN of triangle PQR. So, what is given is AB is equal to PQ, BC is equal to QR and median AM is equal to median PN. What is a median? Median divides the opposite side or the side on which it is drawn. Let us say you draw from this vertex to this line and this is median. So, this will divide this side in two equal parts, right. So, the median are equal. Now, we need to see or we need to show that triangle ABM is congruent to triangle PQN. So, in triangle ABM and triangle PQN, AB is equal to PQ. This is already given, right. And students, I want to tell you that you need to write to prove, right, and then what is given and then you start your proof, okay. I am giving you the hint how to solve the question. You need to write the question yourself, like to prove, and then you write this, right, and what is given, you write all the given data, and then if you need to do any construction, you write construction. If you don't have to do any construction, you simply write proof and then start your proof, okay. So, AB is equal to PQ, it is given, AM is equal to PN, this is also given because these are medians. Now, BM and QN, there is nothing given about these, but BM is half of BC because AM is median, right. So, BC is equal to QR is given. So, I can say half of BC will be equal to half of QR, right, and BM is half of BC and QN is half of QR because AM and PN are medians and divide the opposite sides in two equal parts. So, BM is equal to QN. Now, look at this side by side congruence rule, triangle ABM is congruent to triangle PQN, right. So, this was the first part. Now, I need to prove that ABC is congruent to triangle PQR, right. This is pretty simple because on the basis of this congruence, I can say angle B is equal to angle Q, right, by CPCT. Now I will look at these two triangles, triangle ABC and triangle PQR. In triangle ABC and triangle PQR, AB is given equal to PQ, BC is given equal to QR, and included angle B is equal to included angle Q by CPCT. So, by side angle side congruence rule, triangle ABC is congruent to triangle PQR. Okay. So, this is how we will prove these questions. Okay. BE and CF are two equal altitudes of triangle ABC. Using RHS congruence rule, prove that the triangle ABC is isosceles. Okay. BE and CF. Let us draw this triangle a little big so that we can visualize the problem clearly. This is triangle ABC. BE and CF are two equal altitudes. So, BE, this is one altitude, and CF, this is another altitude, and these are equal. So, this segment is equal to this segment. Using RHS congruence rule, prove that triangle ABC is isosceles. Okay. So, if triangle ABC is isosceles, it will be enough to show that two angles are equal. Two angles of triangle ABC are equal to each other, then this triangle will be an isosceles triangle. So, let us try to prove that. If I look at these two triangles, this triangle here, triangle BCF and triangle BEC. In triangle BFC and triangle CEB, this angle is 90 degrees and this angle in the triangle CEB is 90 degrees. The opposite side to 90 degrees, that is hypotenuse, is common to both the triangles, right? And there is a side which is given as equal in both these triangles. So, by RHS congruence rule, I can say that these two triangles are congruent. So, let me show it to you. BFC BC is equal to side BC, which is common, and let me remind you that this is hypotenuse in both these triangles, right? And angle F is equal to angle E, both are right angles, right? And side FC in triangle BFC is equal to side EB in triangle CEB. It is given information, right? Because the altitudes are of equal length, it is given equal altitudes. So, by RHS congruence rule, triangle BFC is congruent to triangle CEB. Okay, but we need to prove that triangle ABC is isosceles. So, let me talk about these two angles. Angle B in triangle BFC, that is this angle. So, I can give full name to it, FBC. Angle FBC is equal to angle ECB, right? That is this angle. So, base angles of triangle ABC are equal, hence it is an isosceles triangle. Hence, triangle ABC is an isosceles triangle with equal sides AB and AC. AB, which is opposite this angle, and AC, which is opposite this angle, right? This is what we had to show here. Okay, let's move to the next one. ABC is an isosceles triangle with AB equals AC. draw AP perpendicular to BC and show that angle B is equal to angle C. So, this is more or less the same question as we have done earlier. This is triangle ABC and it is isosceles with AB equals AC, and we need to draw AP perpendicular to BC. So, this angle is 90 and this angle is also 90, right. We need to show that angle B, that is this angle, is equal to this angle, right. So, simply by RHS congruency rule we can say that this triangle is congruent to this triangle. Why? Because these two are 90-degree angles, hypotenuse are given as equal, and this side is common to both the triangles. So, by RHS congruence criteria, these two triangles are congruent, hence the corresponding parts of congruent triangles are equal. So, angle B is equal to angle C. This is how you can proceed. So, in triangle ABP and triangle ACP, okay, in these two triangles, AB is equal to AC, it is given, right. Angle APB is equal to angle ABC, both are equal to 90 degrees, and side AP is equal to side AP because this side is common in both these triangles. So, by right angle hypotenuse side congruence criterion, triangle ABP is congruent to triangle ACP, and by CPCT angle B is equal to angle C. Hence proved. So, you look at the question, make a plan in your mind that this is the way I am going to proceed in this question, and prove it in your mind first, then you write the steps, okay. Right. So, this was about this exercise here. I hope the side congruence criterion and right angle hypotenuse side congruence criterion is clear to you. Thank you.